The situation here is identical to the one that we just saw, except that the information given is slightly different. The first object will fall 1.4 meters under the influence of gravity. The second object moves along at a constant x velocity, this time of 2.7 meters per second. Now the first object falls from rest to the ground, and the question is, where is the first object when the second object hits the ground? And we could ask concomitant questions about velocities, and we're going to answer those questions whether they're specifically asked or not, because we need to see how to answer those questions. So the initial y velocity is 0. The initial velocity of this object here is 0 because it's dropped from rest. And as we saw before, then the delta sy is going to be ay delta t squared, which we can solve for delta t, which is going to be 2 times delta sy over delta y. Substituting our 1.4 meters for delta sy and 9.8 meters per second squared for ay, we see that the time is 0.53 seconds. The final y velocity, then, will be the product of the y acceleration and the delta t, 0.53 seconds that we just found, multiplied by the acceleration of gravity gives us 5.2 meters per second. This completes the analysis of the y motion. We know the initial final velocities, the displacement, the time, and of course the acceleration, and we can then easily, if we wish, find the change in velocity or the average velocity. So all that is known now about the second object, since the acceleration is uniform. Okay, since the velocity of the object moving in the horizontal direction is constant, 2.7 meters per second, and we want to know where that object is when the first hits the ground, we're going to multiply that velocity by the 0.53 seconds required for the first object to hit the ground, and we're going to see that the first object travels 1.43 centimeters. Again, we analyze this motion and this motion completely independently, but in order to analyze this motion in this case as opposed to the last one where we were given delta t, this time we're not given delta t, we're just given the y displacement, and we have to find the delta t and then determine how far this moves in that time.